All right. Are we ready? Are we ready? Yep. Okay. I don't have my pen. All right. We're trying to get through this example and hopefully still have time to finish the assignment, right? Yeah, we don't want to do it over the weekend. So there are 80 grams of cobalt 58.
What's that?
Cobalt 58 is, it would be a specific type of cobalt or a specific balance or something. Cobalt is on the periodic table of elements. So we're thinking chemistry here. This is very sciencey. Cobalt 58, which has a half-life of 71 days.
Pretty strong. Is this sauce?
Yep.
Yes, it is. Courtney, I just want to confuse.
How many grams remain after 250 days? So there are 80 grams of cobalt 58, which has a half-life of 71 days. How many grams remain after 250 days? So what wording in the problem tells us which equation we're using? Half-life. So we've got y equals p times 1/2 to the t divided by h. Do we know what the final amount is going to be? Nope. Do we know what the starting value was? It was 80. Do we know what the time is?
250 days.
250 days. And do we know how long the half-life is? 71 days. So that means we have y equals 80 times 1/2. And really the only way you can mess up this problem is if you hit the times button and you don't put the 1/2 in parentheses. You got to put the 1/2 in parentheses. And other than that, you should get it. So 80 times 1/2 to the 250 divided by 71. So what decimal point should we put? And what are the units? Grams, yeah. So after 250 days, there will be about 6.97 grams of cobalt 58 left. Okay, so that was not a math 3 question. That was a math 1 question. That's just plug it in and get it. Now we're going to do the math 3 question. The math 3 question says, how long until 1 gram remains? So what makes that a math 3 question? Yeah, it's a time that we're solving for. That means we're going to have to use logs to get it. We learned how to do that in Math 3, so that's what makes it a more advanced question. So do we know what the y value is this time?
Yes.
What is it? 1. And we are solving for t. That's the new question mark. So we have our final amount is 1 equals our starting amount times 1/2 to the time, we don't know, divided by how long a half-life is, which is 71. We do know that. And then we should just do 80 times 1/2 is 40, right?
Yep.
No. No. Goodness, I tricked all of you. Why?
You really tricked me.
Why can't we do that?
There's an exponent.
It's got a different exponent. You can't multiply those. I tricked you.
You divide 1 by 80.
So, yeah, we're gonna move the 80 to the other side. So one way I think of this is I gotta move the 80 away from the t. I don't want to start multiplying stuff on this side. That doesn't help me. Moving the 80 away from the t does help me. The reason you cannot multiply these is because you can't multiply numbers that have two different bases unless their exponent is identical. Does the 80 have an exponent of t over 71? No, it has an exponent of what? 1. It has an exponent of 1. That's why we can't multiply them. So we're going to move that 80 over to the other side. Whole class is like, yeah, we should multiply those. 40, totally, yeah.
You tricked me.
Totally tricked you. So 1 over 80 equals 1/2 to the t over 71. And what does this form make you think of now? Log, right, Pedro? You texting your friend, make sure they know to do logs. So log base, log base 1/2 of what? 1/80th equals what? T over 71. And how do we finish it? Times 71. We need to zoom in. I got some squinty eyes out there. Yeah, this pencil doesn't write very dark. Ooh,
Yeah, I don't like it.
that light is reflecting.
We like to say 180.
Oh, give it a second. Give it a second.
Oh, we can see. Right there.
There we go. Is that better?
Yeah.
Okay. So now we're going to say times 71 on each side. So we can type this in our calculator. Now my calculator screen probably won't show very well. So 71 times log base 1/2 of 1/80th. So t is approximately what decimal are you guys getting? So 448.86. So the 5 is followed by a 6, tells us to round up. So 448.86. Now our time is typically in years, but what did this problem clearly say? Days. So this is an exception to the rule. Typically we're in years. This problem happens to be in days. And then we got to go ahead and write our sentence. So we're going to say it'll take about 448.86 days before only 1 gram remains.
That's a lot of days.
Yeah. Is that more or less than a year?
More.
More.
It's like
Durr. Durr.
A year like a few months,
A
right?
year like 3 months.
Yeah.
Maybe not even 3, probably like 2. A year or 2 months probably. Just got
All right. So at this point, we are finishing the packet. We have enough information to finish the packet. That is your homework, okay? Finish the packet. And you should be able to maybe do that before you leave. Right?
Right about now.
Oh, my name was Julio.